Thank you, guys. Where did I leave it? Oh, so one way is to break it up using square numbers times whatever, and then I can do that. The other way is to break that number inside all the way down to its parts. And since this is a cube root, I'm looking for groups of three things. And what do I see a group of three of? 2. And what's going to be left inside? 15. I like it. So 2 cube root of 15. Because if I did this the other way, it'd be cube root of 8 times cube root of 15. That's still 2 cube root of 15. Some kind of test for me. Alright. So what the hell? How many extra x's are in there? 1. Alright, cool. So I can do it the same way I did this one. So isn't this the 6th root of x6? Those are the nice ones. And then this extra asshole got in there somehow. So what's the 6th root of x to the 6th? X. Yeah, forget about the absolute value for right now. We're assuming everything's positive. So the 6th root of x to the 6th is x. Is everybody cool with that fact? Square root of x squared is x. Cube root of x cubed is x. 4th root of x to the 4th is x, because they undo each other. The 6th root is the opposite of a 6th power, so of course they kill each other. But what's left inside?
X times x.
That is there. That is still inside. You guys see that? It works the same way this did. Let's do another one. Another one. So what about the 4th root of a to the 15th? No. So not. So desperately not. How many extra a's are there? What number would be good to put here that's lower than 15? What number is a better number? Why would 12 be better? Because I can break 12 up into 4 parts. So how many extra a's are there? 3. So can't I write this as? Right? It's the same thing. How many a's inside? 15. 4th root of a12 times the 4th root of a3. What's the 4th root of a12? And what's 4th root of a? I don't know. Make sure you know what's in there and what's not. Are you stop there for a second? Second?
The last part, explain the last part you just did.
Alright. Are you cool up to here?
Yeah, I'm cool with that.
So the 4th root of a12, 4th root says break it up into 4 parts. Yeah. A cubed times this. Well, I don't have enough a's inside. What's a 4th root need? How many things does it need inside to be able to be done? 4 things. How many things do I have inside? Shit. So this is just going to stay the way it is. Yes, sir.
Square root of x squared is x.
Officially, it's the absolute value of x. So right now, we're saying pretend like all the variables only represent positive numbers. But the main thing there is the square root kills the square. A cube root kills a cube. That's the idea.
Okay, well, if the 6th root of x to the 7th is divided into x to the 6th and x to the 1st, then 6th root of x to the 6th is x.
Good.
Times x.
No. Where is this?
That's...
So I can rewrite this as the 6th root of x6 times the 6th root of x. The 6th root of both of them, right?
That's x.
X times
The 6th root of x.
done. Alright. Do you guys see how that... It's the same thing as this. Why can I not do this right now? There's extra shit. So I take the extra shit out of the way. There's an extra factor of 2. If only that wasn't there, if it was square root of 100, it's an easy question. All right, well, let me do that easy question and then just put the shit on the end. Put the extra shit. Too many shits, Jeff. All right. So the same thing works here. If only that was a 6th power, that would be stupid easy. All right, make it a 6th power times the extra shit. Do the part you can, leave the part you can't. Now, exactly the same idea. Now, here's a shortcut. And this shortcut is so beautiful. I want to show you why it works first, though. Now watch. This is the way you say it. 6 goes into 7 once with 1 left. Holy shit. 4 goes into 15 3 times with 3 left. The way you've said it since whatever grade you first learned division is the way you write it with it's crazy. The left, it means left inside. It's almost too nice to believe. But why does it work that way? Because radicals are fractional powers. So they do work like fractions in that respect. So I am dividing 15 by 4. I don't know if you guys get that. So what would happen here? Well, like, so the 5th root. So now you just go through each one. 5 goes into 11 twice with 1 left. See, I'm leaving some room. 5 goes into 7 once with 2 left. 5 goes into 31 6 times with 1 left. Done. Next problem. Now, what I'm assuming right now, let me make sure my assumption is correct. What I'm assuming right now is that you all understand this kind of problem is easy as hell. That's my assumption I'm making. Is that a correct assumption? Why is that easy? Because I can break everything in there into 7 parts easy. So all I'm saying is, if there's a 22 there, it's like, oh shit. There's just an extra x. So I just keep the extra x in and I do the part that I can. That's the only thing that this is. So if this is easy, then this is only a little tiny bit harder. It's still relatively easy, right? 7 goes into 21. 3 times 7 goes into 70. 10. So the problem would have instead been this. There's 1 extra x and there's 4 extra y's, right? So they should be left. That's the extra shit that should be left. So 7 goes into 22, 3 times with 1 left. The extra x gets left. 7 goes into 74, 10 times with 4. There. That's the extra shit that's there that wasn't there. Now, I understand that on some level this kind of thing we do in math is not satisfying. You're like, well, I don't know shit about that, and I still don't know shit about that. Thank you, math. But this looks better than that. This I understand if you say that does not look better than this. But it actually is. I've actually got a part that's not radical. I've de-radicalized these. Right? It's a big thing nowadays.
So the 7 and the 10 on the outside is just left over.
Yeah, this is the 7th root here, right?
Yeah. So the 7 and the 10, or that's a 3.
That's a 3. Yeah. 7 goes into 22 3 times. 1 left over. 7 goes into 74 10 times. 4 left over. That's the extra that if only it wasn't there, it would have been easy. Okay, maybe. So it's this with a little extra because there was more x's and y's in there. Okay, maybe you guys are with me on this. Maybe. So you'll see a little bit of this in this homework. 10.3. I think we haven't. Let me make sure I'm in the right section here. Yeah, 10.3. I like it. Yep. Alright. This is me trying to remind us what we did, and then I reminded myself that we hadn't really done that yet.
May I ask a question from the work?
Sure. Yeah.
Alright. F of x equals the square root of x plus 2. I think it's over here. So problem number 75 on 10-1.
Oh, the domain. Good. So this is a question I expect to get. So when I don't get this question, I get kind of concerned. So Nathan, you saved everybody's ass. So if it was this, how would I do the domain of this? What's the domain of this? X could be 0 all day long on this problem. Yeah, why? Because the bottom can't be 0. So in English, the bottom, if I have a fractional function, a rational expression, if you want to be technical, what can't happen is the bottom can't be 0. So then I write in math what the bottom is, can't be 0, and then I solve. Alright, so very cool with that. The funny thing is with domain, it's always like that. Not always like this, but always can you say in English what can't happen or what must happen. So here, the bottom must not be 0. Here, the inside has to be what? Or start with what can't it be? What can I not take the square root of? Negative numbers. So therefore, the inside must be positive or 0. Well, then how do I... So the inside must be positive or 0. So then it becomes, how the hell do you write this mathematically?
X plus 2 bigger.
Good. X plus 2. To be positive, any positive number is how related to 0?
Has to be greater.
Bigger than 0. That's positive, right? So it's got to be positive or is equal to 0. There. What's up? Totally can be equal. What's the square root of 0? 0. But you see, so again, the thing I'm saying is the same is not this. That's not what I'm saying is the same. What's the same is, can you say in English what must happen? Write down what you just said, and now translate that into math. You can always do domain this way. I don't know if you guys, again, I've given up on trying to read you. You got me. So then x must be bigger than or equal to negative 2. Which makes sense. Negative 3 is not bigger than negative 2, right? So negative 3 should not work. Negative 3 plus 2 is? Holy shit. So that's, well, it makes sense. I can't use negative 3. It's got to be bigger than or equal to negative 2. Then the inside comes out positive. Nathan, does that make sense? No? Okay.
Yeah.
Yes?
Yes, I mean, it was just one of those questions like from the beginning of the chapter.
Yeah. Domain is always a fundamental question asked about any function you learn. So if I had square root of 7 minus 2x, how do I do this guy's domain? What must be true? The inside has to be greater equal to 0. So the inside has to be greater equal to 0. Solve that. So you translate the question about domain into something you can solve, and then you're done. So how do I solve this?
It's actually greater than
Divide by negative 2.
change the 7.
Good. Alright, so I have to use anything that's less than 7 halves.
So, and
Or
it says to like write an interval in each.
Oh, sure.
So then it's like, it would be 7/2, or negative infinity.
Up to.
7/2.
That's negative when you go down that way, right? A lot of you guys leave that negative off. Oh, sorry, yeah. And then it's allowed to equal, bam, I like it.
If 1 over square x plus 2
Oh, okay. Alright, so is everybody cool now with this? So, very good question. Did this actually happen? I don't know. Or is it just you're curious? You're just curious about it. So the fact that this is inside the radical says it has to be at least 0. But the fact that it's underneath says it can't equal 0. So the one change between this and this is that I can't let it equal 0. So then it's strictly greater than 0. So the radical could handle 0, but why can't the function handle 0? Because this is on the bottom. So I can't say it's greater than or equal to 0. It can only be greater than 0. That's all it can be. Because there's two problems here. The radical is a problem, and the fact that it's on the bottom is a problem. So that further restricts my domain. It makes some more things not usable. Okay. So what about this? M of x equals. No, Jeff, don't make it. What's the domain? Good. Who said that? You are super. Why is it anything? The domain here is all real numbers. Why?
Because 5 can
It's a freaking fifth root. Odd roots are laid back. They can handle anything. So why was this restricted? Why wasn't this everything? Square root. Even root. Shit, they get all freaked out. Odd roots. What's your problem, man? All real numbers. Odd root. But if it was instead this, what I was almost going to write. Is there a problem with the root? Does the root have a problem? No. It can handle odds, negatives or positives, right?
Right.
But what is there another problem?
Yeah,
Yeah, so what can x not be?
it's 0.
That's up. X can't be 0, so it can be everything else. Negative infinity is 0, 0 to infinity, skip 0. So the fifth root does not contribute a problem. It's just the fact that it's underneath. This, it was underneath and it's a square root. Oh shit. 2 problems, right? Okay. Very good question. Yes.
What's the square root of 0 called again?
What? Square root of 0 is just 0. It's not called anything. Alright. Let's see. So I was about to let's get into section 10.4. We did a little tiny bit of 10.4. I'm going to stop talking earlier today. I'm getting tired of competing with that. I got another little handout you guys are going to work on. I'm not going to stop talking yet. Too bad for you. Now remind me, how do I do this? Does everybody see the difference between that and that? The 5 and the 3 are what's here? Coefficients. There they are roots, right? These are called the indexes, the indices of the roots. Doesn't matter what they are. This I can't do because they're not like terms, right? This, all day long, yes.
That's 5 times the square root, 5 times the negative 3 times.
Yeah, it's 5 times the square root of x minus 3 times the square root of x. So I got 5 of these minus 3 of these
It's 2 of these.
is 2 of these. Right? Nothing amazing. All I'm doing is collecting how much I got left. I had 5, somebody stole 3 of them, now I got 2 of them. I don't know what they wanted them for. Oh well. So chain up my radicals. So let me see, make sure let's see. 3 square root of 11, or 3 cube root of 11 minus cube root of 11. What would that be? Yeah. 2 cube root of 11. Okay, cool. I like it. Let that be nice. How do I do any 3 unknowns minus 1 unknown? 3 unknowns minus 1 unknown is 2 unknowns. Whatever the hell that unknown is. That rule can't change. Math doesn't care what you put in here for x. That's how it always works. So the problem we saw yesterday was, what if they're not like terms? What does it take for a radicals to be like terms? They have to have the same insides, base, and the same, everything's got to be the freaking same. I really want you guys, so remember, when you multiply fractions, do you need LCD? No. Hell no. So when you, and that's 1/8. So when you multiply, when you multiply here like this, are these like terms? No, but they have like bases, so I can go ahead and add the powers and put them together. Right. So I don't need like x squared plus x. Can I add x squared and x? Can I?
No.
Hell no. But can I multiply x squared times x? Yes. So I made this point before, and I made it with my Math 90 students last semester. Adding, subtracting always requires much more strict definition of like terms than multiplication and division. Right? They got to be exactly the frickin' same. 3 is something, I better have some amount of the same damn thing, or else I can't put them together. So when you first see this problem, then you might be like, well, shit, Jeff. Well, we've already done some of this, so you're not going to say, well, shit, Jeff. So, do you understand the person that writes this? Do you understand them? You have a little pity for them, right? I'm sorry if this is what you thought. This is so not right. So desperately not right. You can't do this kind of shit. It's just like saying 1/5 minus 1/4 is 1/1. Yay! It's the same kind of mistake. These are not like terms currently. But what can I do?
7 times 4.
Yeah, so this is 2 square root of 4 square root of 7. Minus 4 square root of 7. What's square root of 4?
2.
Times 2. 4 square root of 7 minus 4 square root of 7 is? And you can check it. If you do this in a calculator, 2 times square root of 28 minus 4 times square root of 7 is about 0. Alright, so that's one thing. We talked about that.
Okay, so
Yesterday.
deduct the second part. What
Here?
happens- Yeah.
The 28 is 4 times 7.
What happens to the 2 on the outside?
Because the 2's there. So let me. So all I did right here was square root of 28 is the square root of 4 times the square root of 7. Now why did I do that? Because the square root of 4 is 2. And then 2 times 2 is 4. And now they are like terms, aren't they? So that's one explanation of why we learn how to simplify radicals. And that's only one reason. There's a lot of reasons. So what about this here? This is never going to be like q cubed here, so I mean, I already know that's the cube root in there, right? We're getting closer to us. We struck oil. So here, why did I break this up as 4 and 7? Why not 2 and 14? 2 times 14 is 28, Jeff. Because I can't root either one of square root either one of those. So here I've got cube roots. Now again, I kind of always lean in this direction. I told you I would, and I am currently doing that. You could take 28 and break it down to the 2 times 7 and look for groups of 2 things. I don't mean to talk down about it. It's fine. That way it's perfectly fine. You can do the same thing here. 4 times 10 and 2 times 2 times 2, that's fine. It's a little tiny bit better to force yourself to think in terms of cubes. So what cube goes into 48? 8. So I can rewrite this as the cube root of 8 times the cube root of 5. Now this is a hint. I really want you to understand that that's going to be 2 of these. The only way these are going to be like terms is if that's in there also. And sure enough, 5 goes into 135.
8 times. No. 12, 14, 16.
25.
16 times. 27.
27 times. Right. Calculators, you got this ability, right? You can do this. I love how everybody's just kind of like, 16. No? 19? No? How would I know, Jeff? I don't know. Do something. Do something mathematical to it? I don't know. It's crazy. But I really want you to understand, if you get some ugly ass number, but you got part of the problem done, that is a hint. It won't necessarily work, but that's the only way it would be like terms. If you don't see that, just start dividing this by 8 and 27, and you'll get it. 27 goes into it 5 times. So I can rewrite this as cube root of 27 times the cube root of 5. What's the cube root of 8? 2. What's the cube root of 27? 3. And 3. So you get 2 cube root of 5 plus 6 cube roots of 5 is 8 cube roots of 5.
Again, the same answer but different.
I love it. That's fine.
Where did you get that 6? Or where did you get that 3?
What's cube root of 27?
Okay.
That's why I prefer this way over breaking the number down. Because I can see exactly where that 3 comes from. The other way to do it is to break it down and you can see 3 3s and you put 1 3 outside. That still works. I love it. Okay. How we feel about that? Okay. We have feelings, Jeff. We're just not going to show you. Okay. All right. Last little thing, and then I'll let you guys try this handout. How do you think you do this here? Well, first off, remind me, how do I do this? That's easy shit, right? You should be like, come on, Jeff, give me something good. So how do you? Now, I'm about to say something very strange. None of you even consider this. But why don't I multiply the 2 by the x? That made any damn sense, Jeff. What are you talking about? 2 times 3 you can do. X times x you can do. You multiply the parts of that you can multiply. These are still multiplying each other. I just can't put them together more than they are. Does that? You'll see what I mean here. And of course, then you guys think that's weird. That's what I said. But I love it. All right. So what about? Here's the real problem. 2 square root of 2 minus 5. 3 square root of 2 plus 2. Same problem. You guys notice that?
Yeah.
2 times something I don't know minus, okay, 2 times something I don't know minus the same problem. It works the exact same damn way. So what's this times this? 6 square root of
2 minus 5.
what's square root of 2 times square root of 2? Alright, I like it. Some of you guys say 2,
4.
and it's right, but it's the square root of 4, which is 2. I love it. So let me show every step though. So 2 times 3 is 6, square root of 2 times square root of 2 is square root of 4. If you just write 2 there, I love you. You're beautiful. You're perfect. Square root of 2 times square root of 2 is 2. Square root of 11 times square root of 11 is 11. But just make sure everybody sees where it's coming from.
Is that 2 times the square root of 2 minus 5, or is that 2 times the square root of 2 minus 5?
Yes? What else would it be?
Because
It's the same thing as this.
the 2 would either be the one getting square rooted, or 2 minus 5 would be the one.
Oh, then this would be big across everything. What is that over? That.
Yeah, your stuff's a little. Okay.
Come on now, come on. So the difference between what you're saying is the difference between that and that.
Exactly.
All right, good. So it's obvious which one that is. Dear God, please. There was a student a while back that had a really good idea. This symbol should have like a back wall. You know what I'm saying? This symbol should have a place saying, I stop here. Because one of the biggest problems students have is they rewrite the problem and they make the square root too big. So then they do think that negative 5 is in there with the 2. But please tell me it's obvious that that isn't. That's the square root of 2. Then minus 5, right? If I meant that they were both in there, I have to make the square root symbol across the whole damn thing. And it isn't. So what's inside the square root? Whatever's underneath it. And that's not underneath it, so it's not inside. So I got there, plus
4 square root
4 square root of 2, good.
minus 15 square root
Good, minus 15 square root of 2,
minus 10.
minus 10. You see how that's the same? 6 times the thing squared, plus 4 times the thing, minus 15 times the thing, minus 10. So, and now you can simplify. Now I can do a little bit more than I could here, because it's not really unknown. It's a number. And sure enough, the square root of 4 is 2 times 6, 12. What do I get here?
11 square root.
Minus 11 rad 2.